some specific immune response today. So mostly that's going to be phagocytosis and a bit of T cells and B cells, all that kind of stuff. So the specific immune response, we'll discuss what that means to start with. I actually need to send my notes over to myself, but we'll do a bit of discussion to get everything sort of up to speed first of all. Let me pull my chat open. It doesn't seem like there's too much of a crazy delay today. Okay, let's line it up nicely. How's everyone doing? Supposed to write notes. Obviously the whole purpose of us being here right now is to support you year 12 students completing the content. You will be examined on this. Your exams are going to happen and you are at a disadvantage because you are not going to, you're going to miss out on a couple of months worth of classroom teaching. So those of you, you're probably, how do you feel right now? Do you feel like you're on some kind of a holiday? Lots of students are saying that they're like not doing as much work as they would do at school, which I kind of understand, but obviously at some point it might be a bit of a weird situation where you don't really have like a summer holiday, you just do less work. If you want to take like a solid month off in the summer, 6 weeks off like you normally would do, then you're going to need to kind of do the normal amount of work now. If you're happier with a situation where you sort of do fewer hours or less work now and just keep that going all throughout the summer and you just like trickle that all the way through to September when we're sort of assuming that school or college will resume, then okay, so you feel lost. Well, hopefully, inside of our courses, then we're there to support our students. From next week, we are going to be doing daily lives within our courses and including the study at home exambulance. So it's free to anyone to be able to access. They're just not going to be on YouTube, and we're going to be there daily to support you, to do less teaching, but to do more support and to give you structure, to show you how to use the courses so that you can effectively like study at home and get structure. Okay, well, I'd say to those of you that, yeah, you are going to like next year, if you don't do any sort of work between now and September, then it's going to like next year's going to be a mega struggle. Year 13 is usually pretty tough for A-level biology, but it is going to be super duper hard if you basically go into it with only 2/3 of the AS content complete. And also, the longer that gap is, the more you're going to forget the details that you have done already. Okay, so going back to the original question, should you be writing notes? You might not have time to write notes as you go because I'm going to be going relatively quickly, but obviously you can come back to the recording, which will be on the YouTube, and you can finish any notes and maybe add in some things that I say and don't necessarily write down. So lots of your teachers have said so much work, it still feels, like A-levels is a full-time course. So when students ask us how much work should you be doing, it should be 35 to 40 hours a week, obviously across all your subjects. That is what it should be. A lot of students don't do that much work, but when we're suggesting that that's the recommended amount for a full-time course. Let me just pull up my notes on here and we'll jump in. So what are the sticking points with in fact, before I jump into too much biology, tomorrow we're going to be making some announcements less impactful to you year 12s. Let me know if you're year 12 or year 13 in the chat over there. I just want to know. This one first. Oh, there's something weird going on with okay. Okay, so most of you year 12s will be announcing whether there's about how they're going to be grading the year 13s. We're going to be announcing that tomorrow. I don't know exactly what time. It depends on what time we're allowed to tell you. There may be some additional details that we need to update as well. But okay, so it's good to know most of you year 12s. How many of you give us a yes or a no to whether you have a content guide subscription or an exam guide subscription? So just a yes, no to see how many of you are our subscribers, because those of you that are, we're going to be resuming with these Zooms next week. So mostly no, okay, but those of you that don't have an ultimate guide, content guide, or exam guide subscription, then make sure you're inside the Exambulance. Link is in the description to go to the to sign in. It's totally free, and that's where you'll be able to continue with these live classes from next week. But as I said, I'm not going to do so much teaching next week. I'm going to do more support and drop in questions to help guide you through. Basically, we're just doing a whole bunch of different things to see what works best. Basically, okay, are you ready for a little bit of specific immune response? So what is the specific immune response? Well, it's specific to the pathogen. You've got your non-specific immune response, your skin, barrier to entry. Yeah, it just blocks basically anything. It doesn't matter really what it is. So there's lots of non-specific immune response. Phagocytosis, specific or non-specific? This is my first question to you. Phagocytosis itself. Okay, so phagocytosis, I'm actually going to start with phagocytosis, which is non-specific. So a phagocyte will engulf any pathogen. In fact, it doesn't even have to be a pathogen, dust or bits of smoke particles, things that are foreign and not part of you. The phagocyte is going to go around and engulf and digest or hydrolyze those things. It's obviously forms part of the specific immune response because it has a role as what type of cell. We can put phagocytes into a class of cell that they're going to do something to trigger the specific immune response. What's that? Okay, so absolutely, it destroys all pathogens, or so viruses included in that, bacteria. Could be a fungus, could be a protist, could be any kind of pathogen. Okay, so it's going to trigger the T helper cells, and other white blood cells. So these are all white blood cells: phagocytes, T helper cells, T killer cells, B cells, plasma cells, memory cells. You might have come across neutrophils or monocytes. These are all those. The immune system is mind-bogglingly complex. However, we only learn it in a relatively simple capacity, which is good news. OCR do a little bit more detail on things like cytokines. You might have heard cytokine storms being mentioned in terms of the pathology of COVID-19 and interleukins as well. But they're cell signaling molecules that allow the white blood cells to communicate with one another to coordinate your immune response. But that's OCR students only. Okay, so yeah, the word that I was looking for, and I obviously didn't describe it very well because no one came up with it, was antigen presenting cells. So the role that phagocytes play in triggering the specific immune response is their role as an antigen presenting cell. So the basic headlines of a phagocyte is that it's going to engulf the foreign pathogen. It's going to engulf it into either a phagocytic vacuole, or you could say a phagosome if you're an OCR student. It's going to hydrolyze it using lysosomes, and then it's going to take the antigens from the pathogen and it's going to put it on its cell surface membrane. Basically, that is going to trigger the T helper cells or the T lymphocytes to bring about, to initiate the specific immune response. Now, you might ask the question, why doesn't the T helper cell or the T lymphocyte just recognize the antigen on the pathogen? And why do you need it to be presented on the phagocyte? Well, effectively, that doesn't happen. And it doesn't happen because the T cell needs both the phagocyte. So if this is the phagocyte, normal antigen, and then it presents the pathogen's antigen. So it needs both of these antigens to be present to activate the T lymphocyte to be activated. So without both the phagocyte antigen and the pathogen's antigen being next to each other on the cell surface membrane, that's why the pathogen's antigen on its own does not stimulate the T lymphocyte to bring around the specific immune response. A macrophage is a type of phagocyte. Yeah, I mean, depending on your exam boards, there is not different terminology, but things like neutrophils are not mentioned in the AQA spec. And yeah, You can help each other out in the chat. You've been doing a great job of it so far. Okay, so shall we jump in and take some notes? And I'll go through phagocytosis first, which is technically non-specific, as I've mentioned, but it initiates the specific immune response because it does the antigen presenting side of things. Okay, so let me, oh, I don't need to plug my iPad in. Okay, let's share the old iPad via AirPlay. Okay. Excellent. Okay, so that's there. Okay, what have we got here? Let's choose some red pen. Key terms, always essential. Give me, in fact, I'm going to try and make this a bit more interactive. Give me 5 key terms that relate to the immune system. Give me 5 key terms in the chat, 5 each. If you can put comma separated so they don't just come in as a list, would be lovely, but antibodies. T helper cells, yeah. It's the other type of T cell that you might need to know about. Yeah. Antigens, antibodies, obviously making sure you know which one is which. B lymphocytes. Lymphocyte means basically white blood cell. Antibodies, B cells, memory cells, T killer cells, B memory cells, plasma cells, T killer cells, yeah. Antigen presenting cell, phagocytosis, lysosomes, lysozymes. Oh, there's an Grace, you must be. Opsonization, that's not something that Edexcel are going to test you on. That's very much an OCR. Opsonins, I'm not going to go into opsonins today. You can use the course if you want to go find out, but that's in the OCR course only, because obviously I teach all my courses specifically to the exam that you're going to need. Okay, so let's go with antigens. Is going to be the first one. So these are proteins. They could be glycoproteins. Typically, actually, I'm even going to write glycoproteins. Glycoproteins. Typically, they're proteins, but usually they're glycoproteins on the surface of a cell, which cause, and I've written here in my notes that they cause an immune response. They are, every cell basically is going to have antigens on it. So our skin cells are going to have antigens on it. Our kidney cells are going to have antigens on it. They are proteins on the surface of cells that are specific to the cell type. I think maybe that's a better way of writing it. On the obviously, they can trigger an immune response. So the immune system can recognize, or this allows the immune system to recognize various different things. So pathogens. And I'll do some examples of these. Cells from organisms of the same species. Maybe abnormal body cells, so tumor cells, cancer, carcinoma cells. Abnormal body cells. And also toxins, like chemicals. Some examples of pathogens would be bacteria, could be fungi, could obviously be a virus, it could be protists, as you wish, really. What is a pathogen then? Let's define that next. I'd say it's an organism that causes disease. And sometimes a pathogen is only a pathogen, like E. coli is throughout our digestive system, our alimentary canal. but sometimes those E. coli get into parts of the body where they are not usually there, then that is, it's basically, it can be pathogenic in some tissues and not pathogenic in other tissues. So it's an organism that causes disease. Do it in red. Okay, so it's going to do that in one of two ways. So the disease is the damage to us. It's either going to destroy host cells directly. So that's what a virus is going to do. It's going to go inside. It's going to get its way inside the cell. It's going to hijack the cellular machinery. It's going to make many copies of itself. And it's basically going to cause that cell to explode or to break apart. And it's going to destroy that cell. Or what will happen is that your immune system will come in and recognize that there's a virus infected in it. And then your immune system will destroy your host cell. Or it can also produce toxins. And those toxins can then damage our cells. So the overview of the immune response, how does an antigen stick to a cell? Well, it's a protein embedded in the cell membrane. Anyone else getting reports of blurriness? I'm going to keep going, just let us know. Yeah, I think you can change the quality on your browser. Maybe it's your internet buffering it. So we've got phagocytosis is going to be pretty much the first step, certainly the first step that we're going to come across in A-level biology. You don't need to worry too much about the others. As I said, it's very complex, the immune system. You can do degrees in it. You can do postdoctorate studies in specific parts of the immune response. We just get a very broad overview. So students often get confused in the immune response in the exams because they try and go into too much detail. The questions are actually quite kind to us typically. We've got I'm going to say lymphocytes. Lymphocytes, you might call these T cells. These are cells. Phagocyte is a cell. T cell is probably the T killer cell that physically go into combat with the pathogens. And we call this the cellular response. It's cells fighting cells, although viruses are not cells. So this is the cellular response. And the B cells, or B lymphocytes, what do they make? What do the B cells, what are they responsible for making? And then eventually they divide and they form plasma cells. This is not a key term that anyone apart from the AQA students need to know. So just to let you know, these are going to form the memory cells. But what are they making? How do they fight the infection? How do they fight the pathogen? They secrete antibodies. So this is the humoral response. And the humoral response just means I don't know if you've read any Victorian literature, they used to believe in medicine that there were 4 humors, 4 fluids of the body. I think it was black bile, yellow bile, maybe blood, and something else. But humor just means basically it's traveling in the liquids of the body. So this is everything to do with antibodies. These are the proteins, the antibodies floating around. So it's not a cell that's actually going to bind onto the pathogen. It's going to be the protein, the antibody. Antibodies, I'm going to say, circulate in the blood. But that's really only an AQA thing. But seeing as more than 50% of you do AQA, I think it's worth mentioning at this point. I don't know does anyone know what the humors are? I think it's black bile, yellow bile. I don't even know if it's blood, to be honest with you. Someone, again, can Google it. I'm sure there were 4 humors. It just means like liquids as far as I know. Or someone wants to give me a definition of that. Let's go do it. Yeah, you could call cell response, or you could say the cell-mediated response. You could say cellular-mediated response. Any of those things is fine. But basically, is it a cell attacking the pathogen, or is it the antibody attacking the pathogen? And that tells you whether it's the cellular response or not. Okay, so then looking specifically at phagocytosis, now we've done a bit of an introduction to the immune system. This is the first line of defense. It's non-specific immune response. First line. So once a pathogen is inside you, then your phagocytes are going to respond first, basically, and it's non-specific immune response. But it does initiate the specific response. So this is our phagocyte. In fact, I'm going to just zoom in and move this up a bit. So the phagocyte identifies the foreign antigen. Next step, number 2, it engulfs it into a phagocytic vacuole. I'm going to say it, but when I mean it, I mean the pathogen. I'm going to put this as a key term. OCR students can call this a phagosome if you want, into a phagocytic vacuole. I'm going to draw a diagram for this. In fact, maybe I'm going to draw the diagrams and I'll let the notes catch up afterwards. So I'm going to draw my pathogen as a red blob, and I'm going to draw these triangular antigens on its surface. So this is my pathogen. And my phagocyte is going to, in this diagram at least, is going to be, basically it's going to have lysosomes in there. So the big blob is I'm not going to go into crazy detail here. It's then going to, I suppose this is stage 1, this is stage 2. This is my phagocytic vacuole. Nothing really here is to scale, it's diagrammatic, but the pathogen, let's make that up. So I can maybe label my phagocytic vacuole. You can see what happens here. Obviously, this is going to come around here and it's going to envelop it and engulf it. Engulf is the word that most smart schemes will use. So phagocytosis is nothing to do with the immune. No, phagocytosis does not have a humoral aspect. I'm just summarizing the immune response in general. I'm breaking down the immune response into the 4 major stages: phagocytosis, response to the T cells, response to the B cells, and then the plasma cells, the antibody response. So I was just breaking it down. Okay, so basically now we've got some lysosomes, which are little membrane-filled sacs full of lysozymes. Yeah, I mean, Louis, you will, AQA students can say phagosome. Markers should be, they should mark correct answers. It is a valid key term. It's just not the one you're going to say. I always match my language to the mark scheme of the exam board that I'm using. Just reduce error. If you have an inexperienced marker, they don't know what a phagosome is, they maybe only ever taught AQA, they might not recognize it. It just reduces error. But yes, in general, correct answers will be credited no matter which language you use. That said, I like to be as specific as possible when it comes to the language I use in all my videos. Okay. What next? So we've engulfed this phagocyte. These are lysosomes, lysosomes, which contain lysozymes, which are the enzymes. So the lysosomes, maybe we can draw this moving towards our phagocytic vacuole. So we've got lysosomes fuse with the phagocytic vacuole. And then they release lysozymes. I think there's a Z. Is it lysozymes? Which hydrolyze the pathogen. You could say digest, but hydrolyze is obviously more A-level biology. Physically break it down. So my lysosome fusing with it. Maybe antigens sort of broken off of it. Maybe I'll draw some green dots. Is my lysozymes being released into the phagocytic vacuole and doing its hydrolysis. Okay, so then next up, fourth and final, if I could select the pen, we can say the phagocyte presents the antigen on its surface. I'm going to say the pathogens. Antigens on. It's an antigen presenting cell, which you can't use this as a key term. Is well recognized, APC for antigen presenting cell, but in fact, I'm not going to write the key term down. I'm also going to draw in this one. I've got my phagocyte here. There's no phagocytic vacuole anymore. It sort of dissolves. We might have, yeah, it's basically gone. But what we do have is our antigens here. It's obviously going to do it in multiple places across the phagocyte. But we've also got, I suppose it probably should be in black, seeing as I've got that. I'm going to draw like these black spikes, which are the, maybe I can draw these on the pathogen, on the phagocyte all the time. These are the phagocyte's own antigens. So these are here, these just belong to the phagocyte. I'm drawing these as a spike. Okay, so basically what the T cell is going to do is that T cell is going to come along, and where you've got one of these next to each other, maybe we've got, yeah, maybe I can draw, yeah, we'll probably do it. If this is our receptor on our T cell, so this has a receptor that's specifically this shaped. And it needs both the red pathogens antigen and in this case, the black phagocyte antigen to be next to each other in order to be activated. If we just have the pathogens antigen on its own, then it won't activate the T cell. I mean, it's just a little bit, this is like, I don't know, the T cell receptor. Obviously, all of these actual shapes and images are purely diagrammatic. They're not actually these shapes. These are the tertiary structures of the proteins. They're going to be quite diverse, but this is why it needs the phagocyte to present the antigen and not just the antigen on its own from the pathogen won't stimulate the T cell. And this is then going to trigger the next stage of the specific immune response. Year 13 live class is starting in half an hour, so no, you've not. MHC, you don't need to include. No spec is going to include details of the MHC. Penn and Potts 1990 wrote a paper about the MHC in mice. No, do your teachers teach you MHC? Craziness, madness, in my opinion. Ask them to show you a question requiring knowledge of MHC. It might be in one question stem somewhere or other, but not in the actual, in terms of the content, no. Because, well, your teacher shouldn't, well, what your teacher shouldn't be teaching. If they're teaching you to do the exam, there's an argument to say you want to teach students more in the round than that, but there's so much content in A-level biology. I don't think that that's particularly, I don't think that argument stands all that well. I was actually talking to one of my first year university biology professor last night. I'm contacting some universities to see what they want biology students, year 13 biology students, to be able to do. And so I was talking to one of my old lecturers last night, and yeah, he was saying that in terms of the content, that they A-level prepare students fairly well, but there's some other weak skills that they would like us to prepare. And so I'm basically looking to write some additional material to help universities prepare students, biology students, for biology degrees. It's in the book. Well, the books are useless. The textbook is terrible, especially, well, they're all pretty bad, to be perfectly honest with you. How long we got? It's just like they had to hedge their bets. When were the textbooks written? Textbooks were written in 2015, before any of the exams had been sat. So they didn't have an option but to include all the possible details that could possibly come up, because you can't have an approved textbook that is missing information. So they had to err on the side of too much information. It's the same every year. They don't get the benefit of looking at what the examiners are actually going to ask. I remember there was one marking point about MHC on a question that'd be worth 2 marks. Explain how macrophages present antigens. Yeah, I mean, potentially you can include all correct science, should be credit worthy, but for it to be a mandatory thing that you have to say, there will not be a mandatory describe this or tell me that requires your knowledge of MHC for any exam board. It could be if there's 5 marking points for a 3-mark question, one of them might be involving the MHC, possibly. I mean, but biology is a bottomless pit of knowledge. You know, we are still exploring the science. There is like no limit to how deep the knowledge goes. And obviously at A-level, they have to pick a standard, and MHC is beyond that standard. It's not in the spec. Okay, let's do a bit more on T cells. T cells and B cells. Okay. Let's pull that up so I can keep the chat on the screen. So what are T cells? There's loads of types of T cell, to be perfectly honest with you, but what are the 2 types of T cell that you are going to be coming across in A-level biology? Let's do this. In fact, let's do this as a bit of Q&A to start with, and then I've got 10 minutes. I'll rinse through the diagram. Helper, you can say helper and killer. There are T memory cells, but again, basically only there's one OCR question in the history of A-level biology that requires any knowledge of T memory cells. It's just like, do they exist? Yes or no, tick box. And yes, T memory cells do exist, but for the vast majority of your questions, you can assume that memory cells are B cells, but T memory cells do exist. Okay, I think I actually will. Are you all seeing my screen? I think, yeah. So let's just jump into it. Okay, so we've got T cells or T lymphocytes. Lymphocyte means white blood cell. These are activated by the antigens, by the antigen presenting cells. E.g., our phagocytes. There are 2. This is more AQA shorthand than anyone else, but I'm going to say there are T helper cells. or T helper lymphocytes. I'm going to say cells just to save space, but lymphocyte is the correct term to use. OCR students, I would generally stick with lymphocyte and never go into T cells and just say T cells. AQA students and EdXL students, they will accept T cell and B cell as T helper. Oh, I can fit it in. Lymphocytes. And then we've also got T. I'm going to call them, what am I going to call them here to be generic to everyone? If I was doing an AQA exam, I call them cytotoxic T cells. In fact, I'm going to try and fit cytotoxic T killer cells in. Cytotoxic T killer lymphocytes. These are the ones involved in the cellular response. Those T cells are basically soldiers going to battle to. So what are each of these things to do? A T helper lymphocyte is going to activate or stimulate B cells or B lymphocytes. Lymphocytes. Or T killer cells activate other white blood cells. And again, there's thousands of these things. The cytotoxic T killer cells are going to kill pathogens. And this is the cellular response. The cytotoxic T cells are the T killer cells. They're two different words for the same thing. AQA students will typically call them, and AQA students can abbreviate them as TH and TC cells. I'm pretty sure that's in the specification. If you're not sure, check out my notations and abbreviations document. I've summarized all the abbreviations that you can and can't use. Well, not all the ones that you can use on the exam. B cells. B cells effectively are involved in producing antibodies. Antibodies are proteins that I'm going to say bind to antigens to kill pathogens. That's going to be my definition. You will not be asked. You need to recognize these key terms, not and use them, but not define them. Proteins that bind to antigens to kill. Obviously, they can bind to the toxins. If the pathogen is producing a toxin which is causing the damage, the antigens can neutralize toxins. I've got a full lesson on antibodies. This is just a headline definition. It's not an all-encompassing, like everything about the antibody. So check out the videos in the course if you want the full details on that. So there are many types of B cell, and each has its specific, produces a specific antibody. So there are many. I can't write types of B cell. Each. So antigens basically on the surface of the B cell that have a complementary antibody are going to form an antigen antibody complex. So it's an antigen antibody complex. This activates the B cell with the right antibody. I'm going to call it a lymphocyte here. So this sort of selection process, like which one is complementary, this selected, this process, this is, again, this is more of an AQA key term, although it's all these key terms are valid for everybody to use. It's just which emphasis the mark schemes are going to choose and give marks for. This is the selection process. This activates the specific B cell. This is clonal selection. I'm going to define that here. Clonal selection. So it's only the B cell that forms an antigen antibody complex is selected to divide into plasma cells. Okay, clonal selection is the selection process, and the expansion is when it divides by mitosis to produce many clones of itself. So you're choosing which one in the selection process, and you're expanding them. You're producing many copies with the expansion. The selected B cell divides. So the selected B cell divides by mitosis to produce many copies called plasma cells. That process that I've just written there, called plasma, this process is the clonal expansion phase. Actually, there's lots of red pen on this page here. Let's just zoom in a little bit here. Plasma cells, let's define them. So these are clones of the selected B cell. Or B lymphocyte that have the antibody complementary to the pathogen's antigen. It's not how you spell antigen. Okay, what else do they do? Oh, 1045, nailed it. Okay, so these are, how can we describe these antibodies? They are all the same. What's a way of describing antibodies that are all identical copies of themselves? Clonal expansion is AQA, most definitely. They are clones, yeah, so we would call them singular types of clone, monoclonal. So they make monoclonal antibodies. Each will form the antigen antibody complex with their pathogen. So they will basically, yeah, I stick many, I'm going to say the antibodies here. Antibodies are Y-shaped. They've got a fork in them. They're going to stick many pathogens together. What's the name for that? Pathogens. They form a clump. It is agglutination. They glue them together. So how much space have I got? I'm going to actually do that here. Agglutination. And this means that phagocytes can destroy or engulf many pathogens at once. So instead of doing one at a time, they can destroy multiple. So then after the infection, plasma cells are saved as memory cells. Now, nearly always, we're going to refer to B memory cells. T memory cells do exist. Okay, so this agglutination type thing. I did my pathogen in red previously, so let's have. I'm not going to draw I'm going to draw my antibodies. I'm going to draw this antibody connecting these two and a different antibody connecting these two. So you can see, because they can attach to two different ones at the same time, that's why that hinge protein is really important, because the angle at which they are going to be holding on to two things. Like if you imagine holding on to two different things at the same time that are independent of one another, your arms are going to do a bit like this. So that's why that hinge protein is kind of important. So we basically end up with this clump of pathogens that the phagocyte can then come in and be way more efficient by engulfing all of them at once. Looks like Pac-Man. Okay, let's put that all on the screen. Okay, let's what is the question that's a good question? Are monoclonal antibodies basically identical antibodies? Yes, they are exactly that. They are clones, but obviously you can have this particular plasma cell will divide by clonal expansion to produce many monoclonal antibodies of that particular antibody type. When you're infected by a different pathogen, it'll be a different T cell that's activated, a different B cell that's activated, a different plasma cell that's produced and producing different antibodies. So those monoclonal antibodies will be of a different type. The hinge protein is on the antibody. So if you look at the structure of the antibody, you've got different polypeptide chains, and there's a hinge, the hinge in that protein, which allows the Y shape, the angle of the Y, to change as it's grabbing onto different pathogens. Do the B cells antibodies bind to the antigen present on the phagocyte or antigens on the pathogen? So the B cells are activated by the T helper cells, is what the A-level spec will tell you. So the phagocyte engulfs the pathogen, presents its antigen. The antigen presenting cell, or the phagocyte, is going to activate the T helper cell. The T helper cell, once activated, will recruit or help or stimulate or activate the B cell that has the complementary antibody. That's the flow. I'll just share the iPad once more if you are having difficulty seeing that. That's the full page. This down here, it seems to be the bit that you were. So I'll just read it through because my handwriting is not the best, especially when I'm writing on this iPad stand. So plasma cells, clones of selected B cells, which have an antibody, which have the antibody complementary to the pathogen's antigen. Monoclonal antibodies, they make monoclonal antibodies. They are all the same as one another. Antibodies stick many pathogens together in clumps. This is agglutination. phagocytes can destroy many pathogens at once. This, I suppose, this point follows on. So in my usually arrows, I would do a drop-down arrow for that. And then after the infection, plasma cells are saved as memory cells. Okay, so let me just make sure I'm catching up on these questions. Where does agglutination take place? Well, wherever the pathogen is. Remember, the antibodies are going to be produced by the plasma cell. The antibodies go in the bloodstream. So the antibodies travel in the blood all around the body, but they are only going to form a complex when they meet the pathogen's antigen. And then wherever there's lots of, obviously, if you've got infection in your lungs, that's where the antigens are going to be found by the antibodies, and that's where they're going to form their complexes and clump them all together. If you've got you cut your toe and there's an infection in your toe, then that's where. So the antibodies, the whole point of them is that they can move around in the bloodstream and they will attach only where the pathogen's antigens are. Why is physics better than biology? Well, I mean, that question just doesn't make any sense because it's not true. I'd say physics is super interesting, but for me, it's too removed from the real world. It's too abstract. And it's not, it doesn't have, I can't put myself in the mindset of subatomic particles. It doesn't make any sense to me. It's not intuitive. Biology is life, living things. Life does something that all of the universe is chemistry and physics. There's not much special about that. It does amazing stuff, but biology is where chemistry becomes hereditary. It's at this point in all of the observable universe, we haven't proved that other life organisms exist. I would suspect that life does exist in the universe. It's too big and too old for it to not exist. I might do an ask me anything type thing. So the non-science, well, you can ask me anything you like. Meaning of life, you can ask me what my brand of snowboard I prefer is. You can ask me anything you want. So if you're interested in doing an ask me anything, I'll do that one evening, probably next week, sometime like that. Might schedule one of those if you want to just turn up and you can ask me biology questions or any other questions that you might want. But that's probably, I want to keep these sessions kind of on track. Okay, I've got 5 minutes. I also want to try and scoff some breakfast, which has just been put down next to me. And I'll see you tomorrow for the final one on YouTube. Don't worry, it's not the end. You're just going to have to be inside the exambulance and coming to the live classes. The time is going to change because you've said you want it a bit later in the day. So we're going to make it a bit later in the day. And I'm going to do an hour with you, drop in help. So yep, you basically just need the T helper cells activate the B cells. That's as detailed as we need to get. Check out some questions. Obviously, the exam guide is there. If you've got the course, go delve into the exam guide questions, and you can be able to see how they get applied to the actual how it gets applied to the exam questions.